Did you know that Google Quantum AI just solved one of the biggest bottlenecks in the history of quantum physics? Google's newly unveiled Willow chip can now actively learn from its operational errors and calibrates itself in real time without shutting down the computation. This changes the physics of scalable fault-tolerant quantum computing forever. Watch this video until the very end to understand how quantum AI merged with physical hardware to break world records. Google's quantum breakthrough real-time self-healing. Friends of the digital universe, researchers at Google Quantum AI and DeepMind have bridged a critical gap in quantum hardware scaling. To understand this breakthrough, we must first analyze how classical computers differ from quantum architectures. Classical processors process binary ones and zeros, suppressing microelectrical noise automatically. Quantum processors, however, are fundamentally analog machines, relying on precise physical microwave signals to control fragile qubits. The frequency, amplitude, and phase of these microwave pulses must be dialed in with absolute perfection. Over time, environmental fluctuations, micro-temperature shifts, and material drift quietly alter qubit behavior. Parameters calibrated an hour ago become incorrect, actively introducing operational errors into every running quantum gate. Running a quantum computer today resembles an orchestra constantly slipping out of tune, forcing musicians to halt the performance repeatedly. Historically, engineers managed drift through a blunt method, halting the algorithm, powering down active operations, executing offline calibration routines, and restarting while manageable 4-second-long laboratory trials. This static pause and calibrate strategy fails for long duration algorithms. Complex tasks like chemical simulation or RSA decryption require weeks of uninterrupted runtime. To resolve this structural wall, Google harnessed quantum error correction (QEC) because observing a qubit directly collapses its quantum superposition state. Direct inspection is impossible. Scientists construct robust logical qubits from redundant physical qubits running non-destructive parity checks. Google utilizes neural decoders like AlphaQubit to parse syndrome detection events and deduce error locations. However, while syndrome detectors signal the occurrence of an error, they do not explain why the control hardware drifted. Google's genius lies in assigning a double role to this continuous syndrome data stream. While decoders extract error locations to preserve logical information, the exact same data stream is simultaneously fed to a reinforcement learning RL agent. This agent executes micro adjustments across hardware parameters, discovering real-time correlations between control adjustments and error reduction. The true beauty of this system lies in its localized factor graph architecture. Every individual error detector monitors only a localized neighborhood of quantum gates. Instead of confronting an intractable thousand-dimensional optimization tasks, the RL agent solves thousands of localized, independent subproblems simultaneously. Deployed directly onto Google's Willow processors, the results were extraordinary. On top of exhaustive physics-based tuning and expert human calibration, the RL agent yielded an additional 20% suppression in logical error rates. This breakthrough achieved under one logical error per thousand correction cycles on distance 7 surface cores, making an unprecedented milestone in quantum history. As quantum processors gain self-healing capabilities, how rapidly will autonomous AI unlock the ultimate secrets of nature? Will the combination of reinforcement learning and fault-tolerant quantum computing shatter modern cybersecurity hybrid? Will be exposed in our upcoming episode. Will the combination of reinforcement learning and fault-tolerant quantum computing shatter modern cybersecurity and usher in a new era of molecular discovery? The terrifying power of this quantum AI hybrid will be exposed in our upcoming episode. What do you think about Google's Willow Chip self-tuning? While running, drop your thoughts in the comments below. Smash that like button, hit subscribe, turn on all notifications, and share this video across your network. Join the frontier of AI revolution.